Okay, 6.2, standard units and areas under the standard normal curve. Guys, it's very, very important that you understand that the z value, when we find a z, it's telling us how many standard deviation above the mean or below the mean, okay? So let's look at this first example. Let x be a random variable that represents the length of time it takes a student to complete Dr. Gill's chemistry lab project. From long experience, it is known that x has a normal distribution with mean mu equals 3.6 hours and a standard deviation sigma equals 0.5 hours. Convert each of the following x intervals into standard z intervals. So we have x is greater than or equal to 4.5. So we're going to use our formula now. Instead of x, we're now going to have z. We're still going to have our greater than or equal to, and now we're going to use this formula up here, x minus mu over sigma. So 4.5 minus 3.6 over 0.5. Maintaining my inequality, I come down and I get z is greater than or equal to 1.80. Now this is telling me that this x value of 4.5 hours is 1.8 standard deviations above the mean. Okay. All right, 3 is less than or equal to x is less than or equal to 4. So I'm going to maintain my inequality. First I'm going to change this value of x of 3 into a z. So I'm going to do my x minus mu over sigma. Okay. Is less than or equal to, and instead of x, I'm now putting z, and instead of 4, now we have that x minus mu over sigma. When I work that out, I get negative 1.20 is less than or equal to z is less than or equal to 0.80. Now, if you notice, I'm always going out 2 decimal places on my z's. That's because here in a little bit, we're going to start talking about using a standard normal table or the z table. And it goes out 2 decimal places, so we need 2 also. Okay. So this also tells me that 3 is 1.2 standard deviations below the mean, and the 4 is 0.8 standard deviations above the mean. Okay, let's look at one more. X is less than or equal to 2.5. So x is going to become z. We still have less than or equal to, and then we do that x minus mu over sigma. When we do that, we get z is less than or equal to negative 2.20. Okay, so 2.5 hours is 2.2 standard deviations below the mean. Okay. All right, let's look at this next one. John and Joel are salesmen in different districts. In John's district, the long-term mean sales is $17,319 each month. Long-term mean, that's your mu. With standard deviation, $684. That's sigma. In Joel's district, the long-term mean sales is $21,971 each month. That's Joel's mu. With standard deviation, $495. That's Joel's sigma. Okay. Assume that sales in both districts follow a normal distribution. Okay, that normal distribution tells us we can use z. Last month, John sold $19,214 worth of merchandise, so that's an X value for John, where Joel sold $22,718 worth. That's an X value for Joel. Relative to the buying habits of customers in each district, does this mean that Joel was a better salesman during the last month? So Joel sold, more dollar-wise, but does that mean he's a better salesman? Well, we need to figure that out. So we need to figure out which of these, John or Joel, is further away from the mean, which makes it more unusual, okay? So for John, we're going to take x is that 19,214, and we're going to change it into a z. So his x minus John's mu divided by John's sigma. And we get that John's, that cell is 2.77 standard deviations above the mean. That's pretty unusual, okay? Now Joel's x, the 22,718, and we subtract off his mu and divide by his standard deviation. And we get that for him, that cell's only 1.5 standard deviations away from the mean. So comparatively, John's was more unusual. So he was actually the better salesman that month. All right. Now, this should have said to change a z back into an x, so sorry about that. So we're going to do the same thing. This is the same information we had about Dr. Gill's chemistry lab. Mu's 3.6, sigma's 0.5, but now we're going to go backwards. We're going to have a z, and we want to go back to an x. Okay, this is the same formula as before, just solved for x. So z is less than or equal to -1. So now we're going to go x is less than or equal to, and we're going to take z times sigma plus mu. So our z, -1 times sigma plus mu. Okay, and we get x is less than or equal to 3.1. So we know one standard deviation below the mean is 3.1 hours. Okay. 1 is less than or equal to z is less than or equal to 2. So z times sigma plus mu is less than or equal to x is less than or equal to z times sigma plus mu. So we get 4.1 is less than or equal to x is less than or equal to 4.6. So 4.1 is one standard deviation above the mean. 2 standard deviations above the mean is the 4.6 hours. All right. Z is greater than or equal to 1.5. So x is greater than or equal to z times sigma plus mu. So 1.5 standard deviations above the mean is 4.35 hours. X is greater than or equal to 4.35 hours. Okay. All right, before we get to the table, I'm going to stop, and there will be definitely a part 2.